Our final presenter of the day is going to be Paul Imbrock. He's the PoreShield Technical Lead and a member of the Indiana Soybean Alliance. And he's going to present on his technology today, SMEPS durability enhancers for bridge deck preservation.
All right, thank you for the opportunity to come in here today and speak to you for a moment. As he said, I will be talking to you today about SMEPS, or PoreShield, as we call it with the Indiana Soybean Alliance. We can all pretend here that that's not a Southeast Bridge preservation photo and that I remember to update that, but we'll move on. So a little bit about our background. The Indiana Soybean Alliance is established through checkoff. So the way this works is when soybeans are sold for the first time in the state of Indiana, 0.5% goes into a checkoff fund that goes into spreading demand for the use of soybeans. So trying to create demand side for the farmers so that the price and the also other research in terms of improved acreage and things like that. So I know it sounds like we should all be putting our rings together here, and the Indiana Soybean Alliance is kind of an interesting title, but really what it is just helping the farmers by promoting new technologies that are based in soy. Also, there's at the federal level, the United Soybean Board, which has also helped to fund a lot of this work, especially in the last couple of years. On a personal side, I came into this technology when I was a student at Purdue University. I was a graduate student for Dr. Jason Weiss. He had worked on this quite a bit in the research lab. And it was really ready to kind of make its way into the field, so part of my work there was to do some of the field trials with the Indiana DOT, and then since then I've been working with ISA on helping bring this into the real world. So to understand this technology, and as I said, we kind of call it PoreShield here for industry education. It's a trademark name we've put on it, but it's not a product you can buy. If you go to PoreShield.com, you can find suppliers who sell this patented technology under their own brand names. But PoreShield is just a name we use because it's a little easier for you to remember and take back home to your departments than soy methyl ester polystyrene blends, which is a bit of a mouthful at times, especially when you're trying to explain a new technology. You do have to think a little bit differently here. If you have experience with things like silanes, it may look kind of like that when it goes down, but the way it functions is different. And it kind of, if you heard Dr. Kevern's speech yesterday, there are a lot of products that seek to meet these goals, and they all kind of have their uses where they kind of fit the appropriate puzzle piece. So this can be used in combination with other technologies like silanes, or it can be used standalone. So this development was out of a need for the Indiana DOT to create a more durable pavement joint. Pavement joints were falling apart prematurely, and it was a very significant issue, costing them $1 million per mile to repair and replace those. Really trying to solve the problem of water and salt infiltration like we've talked about a few times today, but in a complex geometry where we've got a saw cut in a pavement where that water and salt is likely to sit and pool and cause an extreme and prolonged exposure to that concrete and really be able to absorb and cause all the nice problems we've talked about, calcium oxychloride formation, salt crystallization, all that good stuff. So this is one of the first field trials here. Actually, in the center there, you're seeing one application on I-65 in Indiana that happened a few months ago. But the photos on either side are our field trials that are now 13 years old. So this pavement was 13 years old actually at the time of the application, and now we're on to 26 years, so we've really spread this out. It had experienced heavy de-icing prior to the treatment. So this is concrete that had already been exposed to over a decade of de-icing. It's a very heavily traveled highway. And then those photos you see there are actually 11 years on, so that was 23 years in the age of the life of the pavement. And the cement paste of the joint face there is really crumbling away, and the aggregate are protruding. It's the exact type of deterioration that INDOT was seeking to prevent by initiating this research project. And utilizing a technology like this one in the pavement joints was really a shift in the school of thought. Previously, what INDOT had done was widen the pavement joints and then put some sort of a physical barrier into their joints to try to keep water and salt from entering the joint, whether that be backer rod and self-leveling silicone, or now I think they've used mostly HMA recently to fill the joint. The idea with PoreShield is that we're going to put something in the joint that is going to be absorbed into the pores of the concrete and protect the concrete itself. Since we've found keeping water and salt out to be a futile effort, especially once you're 10, 15, 20 years down the road, we decided it's better for us to try to protect the concrete when the water and the salt does make its way into the joint. So what makes this different, especially compared to some of the other technologies you may have seen, is that it does not undergo any chemical reaction, no polymerization, and no setting process. So the way you will take it out of the can, no mixing required, and put it right onto the concrete is the same way it will live in the pores, as a liquid hydrophobic material that is a combination of soy methyl ester and polystyrene. So as the soy methyl ester comes into the pores, we basically have a way to mass transport that polystyrene from the surface into the pores of the concrete where it deposits along the pore walls on the way in. So we've put a hydrophobic, viscous fluid material into our pores to block water and salt from coming in the future. And on the way in, we coated the pores with polystyrene so that it'll prevent any chemical reaction like calcium oxychloride from taking place if that exposure does happen in the future. Those pictures you see there at the top are ASTM 666. The two in the middle are PoreShield treated, the one on the left is untreated, and the one on the right is a solvent-based silane. If you really want to see how PoreShield works in action, one thing we have done in the lab is put fluorescent dye into it, treat a sample, allow it to absorb, and then break that sample open and look at it under a black light. And when we do that, you can really see where the PoreShield lives. If you were to put water and salt on the top of that sample, I think it becomes pretty easy to visualize how we've prevented that intrusion with that nice barrier we've created there in the sample and the pore network, and really separated that material on the top that we don't want into the pores from pores that are open and accessible. So this is the result of ASTM 672 that we've modified. This is the result of 70 cycles, so almost 3 times consecutively in a row, with a 40 grams per liter calcium chloride solution that we've put on the surface. You can see the untreated sample on the left-hand side there shows a lot of damage at the top surface. A lot of that has peeled off. This is a cross-sectional image, by the way, so what you see at the top of that picture is what would be the exposed surface of the sample. Very rigid, lots of the cement paste is pulled away. But then when we look below the surface, we see the real tail that will cause that extended deterioration as we go year on year from this point. So all of those cracks around the aggregate and down into the cement paste of the sample are new pathways for water and salt to enter into the future. Whereas when you look at the treated sample on the right, the surface is fairly even and smooth. Again, this is a very aggressive test, so we would expect some deterioration. But then when you look below the sample, there's no cracking. All of those pathways for fluid and water that were created in the untreated sample are prevented from happening in the treated sample. So this provides that really long extended life. Since this material doesn't ever set or polymerize when it's applied, and it's liquid in the pores, if we do get a crack through a treated section, that allows access for air in through those capillaries we've treated. We'll re-engage capillary suction, and that liquid material will actually move into the damaged area and migrate into the pores around the damage so that it provides continued protection. So this makes it a really long-lasting solution for preserving a lot of different types of concrete. This is freeze-thaw damage. You can see ASTM 666 at 300 cycles, well above the failure threshold, and you can really see the tail when you look at the blocks. There's really no damage to speak of at the completion of that test. Some of this data may be repeated if you did hear Dr. Kevern yesterday. I know some of the studies he had talked about are some of the same ones I'm citing. This is one from the Wisconsin Department of Transportation, where they were evaluating different treatments for pavement joints. And they determined that no matter the concrete you're using it on, if you're using fly ash, you would expect a 5.4 times multiplier on service life versus no treatment. If you're not using fly ash to mitigate some of these issues that we're hoping to prevent, you would expect that multiplier goes up to 9 times. So much like Tim said, the percentage of the cost versus the project is so minimal, it seems kind of a no-brainer to be providing that kind of protection to your concrete. The real benefit to this product is the chloride protection that it can provide, by not only coating the pore walls, but keeping the pores filled with that viscous hydrophobic material. We really repel the salt solution and hold it at the surface. So when you look from the first ½ inch in depth of the sample, PoreShield was the highest performing of any of the products they tested, reducing chlorides by over 40%. And then the deeper you go, the better that protection shows through. When you go down another ½ inch, that protection was over 60% reduction in the chloride ion concentration. So as I mentioned, this started as a solution for providing more durable pavement joints. But you can see in the way I've explained the technology that this can really be applied across concrete in general. If you get into really high performance concrete where there's very limited capillary porosity, absorption becomes very difficult, so not quite as applicable in those types of situations. But anything that does contain capillary porosity, this is certainly a great solution. Not only, like I said, can you use this as a standalone to protect the pores and prevent fluid absorption, but you could use it in combination with an epoxy overlay or with the silane coating sort of as your siding and your insulation, right? If your siding starts to break down, your insulation's there to keep you protected. For our ITD project, we're really trying to demonstrate the breadth of applications of PoreShield. One of the first ones we did was a pavement joint treatment that was done this summer with Indiana on I-65. This is, I believe, their 4th or 5th large-scale pavement joint project that they've treated with PoreShield. We did a bridge deck in Buchanan County, Iowa with Brian Kylieber. He's a great county engineer there in Buchanan County who's really willing to try new things. This, I believe, was his 4th or 5th bridge he had treated. And we are still looking for a vertical surface application. We would like to include a vertical surface application because the nature of this technology makes it great for that type of a concrete situation. Our issue in finding these is we always end up selling these projects but not wanting to include them in ITD because there's so much steel in these vertical structures, they don't want to go through the coring and testing process for the next 3 years that could reduce the overall viability of the structure itself. So if anybody does have a vertical concrete surface that they think would be great for this ITD project, please reach out to me and we would be happy to discuss including you. As I said, works on quite a wide variety of concrete, bridge decks, and highway joints. We are working with the company Phoscrete that is including it in mortar patch material. They're including it both as an admixture and a topical application with their Phoscrete Endure products. Precast concrete materials, we've done countless sidewalks, driveways, and patios with major universities, Notre Dame and Purdue University, as well as dozens, or at this point probably hundreds of homeowners, if not thousands. Animal barns has been a big one for us. Obviously, the Indiana Soybean Alliance has pretty strong connections to agriculture. So things like hog slats and hog barns are really aggressive deterioration environments for concrete that really adding some life to that takes away a lot of headaches for farmers. Salt buildings is another one. I know our friend Brian Kylieber in Iowa has just built a new salt building that'll be treating with PoreShield before the winter. Obviously, that's a very aggressive exposure environment for concrete when you're piling salt right up next to it. So any years we can add to the life of that is certainly beneficial. And then walls and parking garages. We're getting quite a few inquiries in all kinds of areas lately that I would not have even expected. One treatment we're doing now is with Whitewater Rapids in North Carolina. It's basically a water park all built on whitewater rafting, a giant lazy river, and they're going to drain it and power wash it and treat the whole thing. Another advantage of PoreShield is that it's safe for the environment. It is made from soy, and it's a USDA certified bio-preferred product, so there's no concern for overspray into water or land. There's no hazardous fumes. It has a completely hazard-free SDS that does not require PPE. Typically, we would recommend as good practice with any chemical, likely gloves and glasses, but nothing is required. You can feel good about using it. As I said, it's a USDA bio-preferred product. It supports U.S. agriculture from the raw material supply. It's very low VOC, 43.3 grams per liter, puts it well below all of the national standards, the strictest national standard being California Air Resource Board at 100 grams per liter. So we're even less than 50% of that limitation. And then, as we said, safe for applicators, no PPE required, and safe for the environment. Another great advantage of this is that it cleans up just with soap and water. So other materials, you may need solvents or things like that for your cleanup process, and that is certainly not required here on human skin or on equipment. So I know I kind of went through that pretty quickly there, but it's the last one of the day, and I'm sure people are ready to kind of get to their evening. So if anybody has questions, I'd be happy to take them.
So I had one. I assume that the surface needs to be dry for application, and I assume you probably want pretty low humidity in the concrete pours as well. Is there a period of time that you want without any water or rain on the surface before you apply it?
Yep, you really hit the nail on the head. The key to a good application is having a dry pour network that is ready for absorption. That's going to pull that in. So typically what we would recommend is not to apply within 24 hours of a rainfall, and that should be sufficient. If you really wanted to be cautious and you were in sort of these types of months where the dew point is right there, especially in the mornings, then maybe you would want to extend that to 36, 48 hours after a rainfall, or wait till the afternoon to try to go ahead and do your application. But at the end of the day, really that's going to affect the absorption rate more than anything. So unless you're concerned about immediately opening the thing you're treating to traffic, it's really just going to take longer for that to absorb into the concrete's pores. All right, thanks.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.